In this short section, we'll go over some more advanced formulas to find the area of a triangle. Precalculus Online starts now. Section 8.4, the area of a triangle. So what are some of the formulas for the area of a triangle that we have? So number one, and I should mention that a lot of times people use K to represent the area of a triangle because A is usually taken up by the vertex of a triangle. So K is going to be the capital K is the area of a triangle in this section. So the first one that you're all familiar with is 1/2 of base times height. Now where does this come from? Well, if we just have a triangle here, like so, then the height is the perpendicular height from a vertex down to the base. And then this is the base down here. And where this comes from is the fact that if we draw lines that are parallel to the height at each vertex other than the one that we have, and make them so that they go through that point, then what you've created is a rectangle. And if we sort of subdivide the rectangle by equal parts here, you see that we have a little piece here on the left where 1 and 2 are the same because that's a rectangle with a diagonal, and a diagonal splits a rectangle exactly in half. And on the right side we have another little rectangle with a diagonal, and then parts 3 and 4 are the same. So 1 plus 2 plus 3 plus 4 is the entire area of the rectangle, but 1 and 2 are equal, and 3 and 4 are equal, so that makes the area of the triangle, 2 and 4, equal to exactly half of the area of the rectangle. You probably remember that from high school or middle school or wherever you started talking about triangles. So that's one that we use. It's really good. Now from this we can actually develop another formula that's more useful in trigonometry. So let's start with K is equal to 1/2 base times height. And let me draw a triangle here. And let's have the height right here. So the height is there. Now if I have side B here and angle C, then this must be side A. But what is the formula for the height? Well, if you remember from earlier lessons in this chapter, we know that the sine of C is equal to the opposite over the hypotenuse. The opposite of C, in this case, with reference to this right angle here, is H. And the hypotenuse of this triangle that's on the left is A. So if I solve that for H, I get A sine of C. So that's something that you should always remember, that the height from a triangle is the hypotenuse times the sine of the angle that is opposite the height you're trying to get. It's immensely helpful. Alright, so if I take this little piece of information here and I plug it into my area formula, I get 1/2. B is the base, but it's also this side B down here at the bottom. And H is now A times the sine of C, and that gives us the formula most commonly written like this: 1/2 AB times the sine of C. And the way that you can remember this, because the letters may change, is that you have the product of two sides of a triangle, and then C is the included angle. It's the angle in between those two sides. And so when you have two sides and the angle included, then you can find the area of that triangle. Example 1, find the area of the triangle with sides 6 and 8 and an included angle of 45 degrees. So I'll just draw it right here. Here's 45 degrees, here's 6, here's 8. There's our triangle. The area is going to be 1/2 times 6 times 8 times the sine of 45 degrees. And 45 is one of our common angles, so we can work this out exactly. 1/2 of 6 is 3. 3 times 8 is 24. The sine of 45 is root 2 over 2. And so the area is 12 root 2. So if you were on a non-calculator part, the answer would be 12 root 2. If you did have access to a calculator, you could write the answer as 16.97. Heron's formula says the following. The area K of a triangle with sides A, B, and C is K is equal to the square root of S times S minus A times S minus B times S minus C, where S is the semi-perimeter. It's half the perimeter. So you just add up all the sides and divide by 2. Example 2. Find the area of a triangle whose sides are 8, 12, and 13, round to 2 decimal places. So the first thing you want to find is the semi-perimeter. So we'll take half of 8 plus 12 plus 13, and that's going to be 33 over 2, or 16.5. And then we'll use Heron's formula. So it's going to be the square root of 16.5 times 16.5 minus 8 times 16.5 minus 12 times 16.5 minus 13. Plug that into the calculator and you get 47.00. It's not exactly 47, but it does round to 47.00.